Software development has always been plagued by a lot of problems. One of the most important problems that it is plagued by is the deployment process. Previously, we used to rely on legacy methods such as, deploying on virtual machines. But these days, a lot of companies have shifted away from that model and they've started making use of containers. And to be more specific, they've started using Docker containers. So it has become very important these days to understand how these containers are used in the deployment process. Doesn't matter who you are you a DevOps engineer or a software developer? If you're working in the software development industry, you need to know about this. So in this video, we'll be detailing all the things you need to know to understand what Docker exactly is in the most simplest of the explanations. And also, guys, we here at Great Learning have started something amazing called Great Learning Academy, where you have more than 80 plus free courses that you guys can go ahead and enroll for and earn a free certificate for yourself. Now, you can do this by heading to our website, greatlearning.in/academy, or go ahead and download our app on your phone and enroll from there. And also, guys, don't forget to hit the bell icon and subscribe to our channel to not miss out on any of our amazing content in future. So now let us begin this video. What is Docker? In this video, we'll be discussing many different things like what is containerization? What is containerization in respect to virtual machines? What is the need of containerization? What is Docker to do in all of this? And what are the benefits of using Docker? So let's get started by, discussing the issues we used to face before containerization. Now, this is an important thing to discuss because we want to know why containerization is there in software development in the first place. To understand this, we have to see what used to happen before containerization was a thing. So let's imagine a standard delivery pipeline. We have a developer. This developer writes some code, and this code is taken together with the dependencies. These dependencies can be your libraries or your functions. They're taken together with the code and they're built. So the process of building happens, the code becomes an executable file, and then it goes to the tester. Now the tester starts testing this build for various different things. He will do unit testing, acceptance testing, integration testing, and all the different types of various testings there are. He wants to make sure that the product is as, perfect as possible, and it meets all of the requirements that were discussed in the requirements phase of the whole software development process. So if he thinks that the software is not up to the mark, he notifies the developer of the same, and then the developer starts rectifying that mistake. Now, once the developer has, finished rectifying the mistake, the whole thing repeats where the developer sends the code again. The code is taken with its dependencies, the libraries and functions. They're built into a single executable, and they go to the tester again, and the tester tests it again for all the various different things. Now, this time the tester says, okay, it's fine to go ahead for deployment. So this software goes ahead for deployment. So this is a very simple yet standard delivery pipeline, right? So it's not obviously going to be like this. You'll have a lot of various requirements that will change how a certain software delivery pipeline will look like. But this is a standard, right? So keep this in mind. Now let's talk about what are the issues that can occur in such a pipeline. To understand those issues that can occur, let's start discussing the environments that the developers and testers use. So let's look at the developer's environment. Now let's take up a scenario also in our minds. Let's say that the developer is a backend developer. So let's look at his environment. So he has a CentOS operating system. That's the company standard that's being used. And he has PyTest 5.4.3, the software he's using for testing his Django backend code. And he's using the PyCharm integrated development environment. And he's writing the code in Django, that is your Python framework. And he has certain dependencies so that the code can run. Right? These can be the frameworks or the libraries or the functions that are used to make the code run. So on his computer, this developer has made sure that the code runs. He's used the latest version of PyTest because that's what works with his code. That's what his requirements make him use. So these things form his environment completely. Now let's look at the tester's environment. So the tester has a similar environment, but you'll see a little bit, of different versions. So you see that the CentOS operating system is again being used, but the PyTest is of the older version. It's
5.3.0, and the integrated development environment he's using is Spider. But he's working on the same code. He's working on the same Django backend code, and he's working on the same dependencies. So the environments are pretty same, but they have some differences. So what happens when they have these kind of differences? So let's say that the developer, he's made sure the code runs completely fine on his system. He's fine-tuned the code so that it can run completely normal on his system. He says that this code runs fine on my computer because he's made sure that it runs fine on his computer. Maybe in the starting it didn't run, so he corrected a lot of his mistakes by using some other version of a certain thing and made sure that the code runs on his computer, because that's his job, right? And then the code goes to the tester. Now the tester tries to do the same thing, but he doesn't know exactly about the context of the code he's working on, because he won't always know it. He will know through the documentation, right, and through the meetings and the discussion with the developer, but he won't always know the exact context. So he tries to run the same code on his system, but this time he says, the code does not run. So he says that this code does not run on my system. Now you can see that it's the same code and it's the same dependencies, but the code is not running on one system while it's running on the other. Now, why is this the case? To understand this, we looked at the environments. So if I bring up the developer environment and the test environment, you can see that there are two differences, that the developer is using PyTest 5.4.3 and PyCharm IDE, and the test is using PyTest 5.3.0, and he's using the integrated development environment Spider. Now he's using PyTest to perform, they're using PyTest to perform all the test cases. Even the developer runs his own, smaller test cases. He wants to make sure that, all the basic things are running, whereas the tester also wants to do that. But the difference is that they're using different versions. Now, this won't always be the case, but sometimes when the versions of a particular software are different, the compatibility issues start to occur. Now, this is very clear when you're working with Java. So all of those people, who have worked with Java know that Java 8 and Java 11 don't always have the perfect compatibility. Sometimes code runs on one and it doesn't run on the other. Sometimes it runs on both, right? Now, these people have a lot of headache already on their mind. They have to deliver software on a certain deadline. Compatibility issues should not be one of those headaches that should be on their head, right? So to resolve this, we make use of containerization technology, right? So now let's see what happens when we introduce containers. So when we start using containers, we see that the developer and testers don't have any problem at all. Now, why is this so? How does container solve the issue that we were facing? Now, that's a very interesting topic, which we will now discuss when we talk about what is a container. So let's see what is a container. Now, containers are software that wrap up all the parts of a code and all of its dependencies into a single deployable unit that can be used on different systems and servers. So you have your code and libraries, which is put inside of a container, right? So this is exactly what's happening. You're taking your code, your libraries, and even your operating systems and putting them into one container. So imagine this container as a box that contains all the integral information, software, tools, and the source code itself that is required to run the source code. So basically it's like a VM where you're running everything inside of it. So this basically removes any compatibility issues we may have had earlier. Now, this is so because in the diagram, you can see that the container is the one that is being passed along. The developer takes the container, puts all of the necessary items inside of that container. This is the code, these are the dependencies, and this is the environment, like that is the operating system. And he shifts all of it together in one container and gives it to the tester. Now, tester takes this container and he executes the code and that runs test scripts inside of the container itself. So this way, the code is not interacting with the outside or the host system. So this way, even if the developer and the tester have different systems or different versions of specific, tools, it does not really affect how the code is working in their systems, because the code is just, being shipped in a package and it's being executed inside of that package itself. So this removes all of the compatibility issues that may have occurred in their systems earlier, because the developer specifically added in the container the CentOS operating system, the PyTest 5.4.3, and he put in the code and the dependencies all together and he gave it to the tester. So the tester doesn't have to use his own PyTest. He already has everything he needs to execute his test scripts inside of that container. So this way, we remove any possibilities of having compatibility issues. Now, the great thing about containers is that they are very portable and they are platform independent. They can be executed in certain platforms without having any issues themselves. So that's where they're amazing, right? So again, let me reiterate, containers are software that wrap up all the parts of a code and all of its dependency into a single deployment unit that can be used in different systems and servers. So, that's what containers do, and that's what containers are. Alright, so you can basically create multiple containers also, and you can launch these multiple containers together to form microservices which can be easily managed using any of the orchestration service. So if you have multiple containers and each of these containers contain different parts of a code, then you are forming a microsystems type architecture, and you can handle them, all of them together, using either Docker Swarm, Kubernetes, or any other tools that are available out there for orchestration. Alright, so to understand containers better, we will go ahead and compare containers to virtual machines. Remember, I told you guys to think of containers as virtual machines? They're actually not the same thing, they're different. So we will go ahead and take a container and we'll take a VM and we'll compare them using a set of criteria. So let's compare them. So here's the criteria that we've used. We are going to compare them based on the operating systems, the architecture that is being used, the isolation that they both provide, the efficiency with which they can do certain tasks, the portability of each of them, the scalability, and lastly, deployment. So this will give you guys a better idea of what containers are and how we can use them. So let's look at the operating systems of the containers versus VMs. So with containers, they only contain the bare minimum parts of an operating system that is required to run the software. So like we discussed in our example, right, the CentOS operating system, it will not be completely included in the container. Only the bare minimum parts of it that are required to run the software are included in the container. Now, this is important because you don't necessarily have to include everything of a particular operating system. Let's say you're working with a Windows container. So in that container, you will only have the basic parts that run a Windows operating system. You won't have its GUI because you don't need the Windows system GUI to run the software inside of it. You need the Windows operating system itself. So making updates in containers is very easy and it's very simple to do for the operating system. Whereas with VMs, right, the virtual machines, they contain the complete operating system that is normally used on systems for general purpose. Like the normal everyday Windows system we use, if you wanted to run a VM, we have to run the whole operating system on it. So this way it eats up a lot of resources, and updates are usually very time consuming and they're very tough. So you can see how containers are much better in this scenario where they only have the bare minimum parts versus the whole whole blown guest operating system. Alright, so now let's move on to study the architecture of each of them. How do they occupy space in the host operating system? Now, both containers and VMs, they are independent machines, but they don't run independently. They need a host server or host system to run on. So we have a host operating system, which is on some hardware, and inside of it, you can see there are apps and services and kernel. So container basically occupies a very small space where it, basically uses any of the resources it needs from the kernel itself directly. It has its own apps and services, but it does not, it's not completely isolated from the whole operating system. It does not form its own operating system that is based on the hardware. You can see that the case is totally different with the virtual machines here, where the host operating system is its self-contained thing and the virtual machine is its own self-contained thing, where you definitely interact with the virtual machines using the operating system, but then the whole resource management is handled by someone else. Like you basically use hypervisor to allocate resources in a virtual machine. We will not talk about it. It's a different topic altogether. So just understand a hypervisor used in virtual machines. So you can see with virtual machines you have apps and services and it has its own kernel. Whereas with the container, it does not have its own kernel. It basically makes use of the operating system that is already present kernel. So it kind of acts like a normal software or a normal program, the container versus the virtual machine. So this is how the architectures differ from each other. Alright, so now let's go ahead and talk about isolation in containers versus in virtual machines. So the isolation provided by a container isn't as complete as of a VM, but it is adequate enough. Whereas with virtual machines, they provide complete isolation from the concerning host system, and they're also way more secure. This is because, the virtual machines have their own operating system where they have their own kernel, their own apps and services, and they have very limited interaction with the host operating system. Whereas containers act as, programs or softwares within the operating system itself. They're not that isolated. Now, the isolation with containers is adequate, whereas with VMs, it's much, much better, right? With VMs, if you have any malware that is affecting the host system, it will, barely affect the virtual machine. So that way, VM is way more secure. So you can see the difference over here in the isolation policies for containers and virtual machines. Then let's talk about efficiency. The differences between the containers efficiency and virtual machines efficiency. So containers are way more efficient as they utilize the most necessary parts of the operating system only. They act like any other software on the host system. Whereas with VMs are less efficient as they have to manage full-blown guest operating systems. VMs have to access the host resources through a hypervisor. So you can see with containers, they only need very little, resources because they're making use of, only the bare minimum parts of an operating system. They're not making use of the whole thing. And since they're not making use of the whole thing, they don't need that many resources. This makes them more efficient. You can run way more containers you can do on the same resources on which you can run a set number of VMs. So if you had like 3 VMs, you could run them on maybe 30 resources. Then for 30 resources you could run like 6 containers or 10 containers. So this way containers give us more efficiency compared to virtual machines who have to handle the whole guest operating system. So they have to utilize way more resources. Portability. So let's talk about the differences in containers portability versus VMs portability. So containers are self-contained environments that can be easily used on different operating systems. Whereas VMs aren't that easily ported with the same settings from one operating system to another, because again the whole having being lightweight versus heavyweight. So containers are very lightweight and they're self-contained environments, so they're portable across multiple platforms, and that is the whole purpose of containers also, where you use them to maintain a consistent environment across different platforms. So they're designed in such a way. But with VMs, this isn't the case. It's very not difficult, but it is very time consuming, and you have to put in a lot of effort to shift one VM from one system to another. So this way, container shows more promise in portability versus virtual machines. Scalability. Now, scalability is important when we're talking about a growth in a company, or having an auto scaling feature depending on how many users, how many resources you have, and how many services you can provide at a time. So let's compare that for containers versus virtual machines. So with containers, they are very easy to scale. They can be easily added and removed based on requirements due to their lightweight. Whereas with virtual machines, they aren't that easily scalable as they're very heavy in nature. Since containers are such lightweight contenders, you can easily just take them out of a cluster and put new ones in the cluster if you want to. So that way you can see the promise of scalability that containers have versus virtual machines. Virtual machines handle big OS, big operating systems, so it takes time to remove them, add them into the whole architecture, and they use a lot of resources also. So you have to think about the resource management that is going into the managing all of the different virtual machines you have in a set cluster. So this way again containers get the upper hand with the scalability they offer for software development. Now let's talk about deployment. So deployment is again important when you talk about software development, because you have to give an end product to the user, and the end product you're giving to the user should be very easily managed and should be very easy to maintain. The upkeep for the software should be low. So with containers, you can see the containers can be deployed easily using the Docker CLI or making use of cloud services such as AWS and Azure. And similarly with VMs, VMs can be deployed using PowerShell or by using, Virtual Machine Manager or using cloud services such as AWS and Azure. So you have a lot of options for containers as well as VMs. So containers, you have, the management part is much more easier because you have a lot of orchestration tools that are specifically designed to, launch these smaller lightweight containers in a cluster, manage these clusters, and scale them, auto scale them based on requirements. So this way, again, you can see how the deployment happens with containers as well as with VMs. You have a lot of different services that help you do the deployment. So these are the different, differences between a container and a virtual machine. So I hope that gave you guys a better idea of what containers are and how are they different from virtual machines. In conclusion, containers are lightweight virtual machines. You can think of them like that, and they have some, they have some unique advantages. So we will talk about this right now. Why do we need containers? So there are two important aspects to containers. One of them we've already discussed. One aspect is that they give us the ability to have consistent development environments across our delivery pipelines. So if you guys remember when we were talking about the standard delivery pipeline, that the developer and the tester had certain differences in the environment that they were making use of, and because of the differences in the environments, they were having compatibility issues, which was a big headache because they already have to worry about delivering a product slash service, and they shouldn't be worrying about compatibility issues. And this way, containers really helped us out, help them out, by giving them consistent environment, making sure that everything you need to execute a software is inside of a container itself. You have the operating system, you have all the dependencies, the code, and the tools that are needed to execute the code inside that one container, and you just pass the container across the whole different set of environments. And this way the developers and testers don't see any compatibility issues, and they're successful in developing, testing, building, and deploying the code. So this way we keep consistent development environments. There is another reason why containers are very significant in software development, and that reason is because of microservices. So when you talk about software development these days, you don't talk about monolithic architectures where you have like one single file which has all of the code. You usually divide the software application into different parts. It can be 5 parts or 6 parts, depending on how many services you're providing within your product. So let's say you are a food delivery app. We'll take that example again, where you have to give your customers many different options. You have to tell them how many restaurants are there nearby. That's one feature. There's a payment feature, and there's a tracking feature, how long your order is going to be taking, and there's a grocery shopping feature where you can directly contact the grocery shops nearby, and there's a account managing feature, there's a subscription feature. There are a lot of different features, and all of these different features are worked on by different teams, and they create these features in iterative process where they release the better versions of these features in regular successions after getting feedback from customers and teammates alike. So these features basically together form the whole application. So if you look inside an Android application, you see that there are multiple features, right? And these multiple features together combine to form the single software. And that's where the microservices architecture comes in. It's basically saying that you have multiple different services. You have multiple different microservices. And containers help us in creating a microservices architecture by helping us contain these services together. So you have 5 services, let's say, and all of them are connected together by making use of containers. You keep these services inside of these containers, and these containers are inside one cluster, and they talk to each other inside this cluster for integration purposes. You can scale them based on your requirements, and you can scale either one feature itself or the whole software itself based on what you need to do. So this way you can see that there are 2 aspects of why containers are very much needed and why they are so helpful in software development process. So now that we have completely understood what containers are, we can move on to learn about Docker. What is Docker? So Docker is basically a containerization tool. It is a tool that helps us in developing, building, deploying, and executing software in isolation. It helps us to do so by creating containers that completely wrap up a software. So we talked so much about these containers, right? So who creates these containers? How do we create them? So that's where Docker comes in. Docker basically helps us to create these multiple containers in which we can contain our application slash software. And once we have contained it, we can go ahead and perform all the different things we do in software development. That is develop the code, that is, build the code, that is test the code, and, deploy the code, monitor the code. All of it happens, in these multiple containers that we use to contain our software. So you can see that, you have an application. That application is, contained in multiple containers, and then it goes ahead for deployment. Now, a good thing about, using Docker is that, creating containers using Docker creates a layer of security around the software. This is because of how secure the Docker containers are. Now, there are a lot of different types of containers you can use, like created by different tools. You can use the LXC containers. You can use the RKT containers. Now, the whole concept of containerization isn't something, that, Docker has created. The idea of containerization has been there for a long time. It was in people's mind, and people were actually implementing some form of it. The thing is that Docker popularized the idea of it. It made it very easy to use containers, and orchestrate these containers. And Docker it's an open source tool, so you can go ahead and learn from Docker, using their open source community editions. But there are also enterprise editions also. If you're looking for that, you can go ahead and use them for your organization. Now, it was developed in the year of 2013, and since then it's been one of the most popular containerization tools that a lot of people use. Now, you may use a different orchestration service to handle all of these containers, but a lot of people definitely gravitate towards using these containers that are created by Docker. Alright, so why Docker itself? So on their website, they list a lot of different reasons. Now, Docker is a company, so they do have to make money. So they do, try to sell their product. So they tell us why you need to use Docker. So let's see these reasons that they've given us. So it's simple. Yeah. So what they say is true. Docker is pretty simple. You can use Docker CLI. You can learn it in 1 hour or even less. And it's very fast. Yes. When it comes to deployment purposes, Docker is very fast in doing that. It provides you the ability to have easy collaboration, which is again true. If you have any images for Docker, then you can easily upload them to a central repository, or even to Docker's own Docker registry, where you can store your Docker images and share it with your teammates, or keep it public so that anyone can use. So definitely true. Yeah, it has very easy collaboration feature. Built for developers by developers. So it was built by a developer. So they took in consideration of what would a developer look for, and they developed the container in such a way. And then Docker community. So they say that the Docker has a very big community, and that's true. Docker has a very large community since it's a very popular open source tool. A lot of people, tend to contribute to Docker, and this way they give it a lot of other features and other parts to Docker. They provide contributions to those, so that everyone else can benefit from it. So yeah, it has a very big community also. So these are all the different reasons you should go ahead and use Docker. And they're kind of true. They all make sense, and they actually do benefit us in software development.
So guys, that was our video on what is Docker. I hope you guys understood our easy explanation on what it is and how it helps us to solve a very big problem that used to be there in the software development industry or in the software development process. And again guys, go ahead and give us a like and subscribe to our channel to not miss out on any of our future amazing content. And finally, thank you so much for watching.